Are there any questions on that? All right, let's go back to the notes then. So I gotta stop sharing this. All right. So here's another one that's a little bit different. Right here, I'm giving you the graph, and you need to find the quadratic function. Okay, how do we do that? Well, notice that the graph changes direction. Notice it looks like a parabola. So even though I have it in the title, we know this has to be a quadratic function. The graph, this is the graph of a quadratic function. The vertex, that's where it changes direction, right? That's here, 1, -4. I mean, there are other points on the graph. As you can see, we have -1, 0, 3, 0. We also have 0, -3. But since we know the vertex, we know what h and k are. The point hk is equal to 1, -4. So h is 1, k is -4. So that's what we get. Okay? Now, that's what the vertex is. So we have h, so hk is 1, -4. So h is 1, k is -4, like so. But we have to figure out what a is, right? So again, we need another point the graph passes through. And we have 3 options here. Let's see, what did I do? I used 3, 0, I think. Yeah. So I used the point 3, 0. But what is this saying? This is saying when x is 3, y must be 0. Or f of 3, in other words, has to be 0. You know, remember, any point on the graph is of the form x comma f of x. So let me, yeah, that's fine. I've said that before. It's in the notes from before, earlier in the course. But anyway, when x is 3, the output has to be 0. Okay? So we have 0 equals a times 3 minus 0 squared, 3 minus 1 squared, excuse me, minus 4. And now, right, we can figure out what a is. Well, here we have 2 squared minus 4. So we have 4a minus 4, right? We simplified a bit. So 0 then is equal to 4 times a minus 4. So we have to solve for a. And as you can see, I'm showing all the steps. You know, again, you really want to make sure you can do that. Okay? Okay. So here we have 0 equals 4 times a minus 4. So we add 4 to both sides. Then we divide by 4 because we want a all alone. So we get a is equal to 1. So we get y equals x minus 1 squared minus 4. And that's what we get. I mean, you could graph it, I guess, in Desmos to see if you get the same graph. But I don't want to keep bouncing back and forth between the notes and Desmos. So we have this. Okay. Do you have any questions about this one? This next one is, oh no. Okay. Well, here's another example then. Let's solve this this equation. Okay. Now remember, you have a polynomial, okay? So it's not quadratic. So at first it might seem, well, we can't solve this. He didn't show us how to solve this. This is degree 3. But notice that every term here has an x in it. So at the very least, we can factor out x. But to really help us, let's get the GCF. All right. So here we have the coefficients are what? They're 6, 9, and -6. Well, the greatest common factor among those is just 3. You know, you can list all the factors if you want, but it turns out to be 3. The smallest the smallest exponent of x, right? We have 3, x cubed, 2, x squared, and x to the first. M is 1. We have m is 1. So that tells us the GCF is 3 times x to the first, which is just 3x. So as you can see, we're factoring it out. Excuse me. Okay, so the 3x is in front. Then we have to divide to see what's left over, right? And when you divide, you have to divide into each term. So we have 3x, right? So we have 6x cubed over 3x, right? Remember, 6 over 3 we know is 2. You subtract the exponents, so that's how we get 2x squared here. 9 over 3 is 3. X squared over x. Subtract the exponents, you get just x. 6x over 3x, the x's cancel. 6 over 3 is negative. 6 over 3 is 2, so the minus here. Okay, good. But now we have to handle this thing. I mean, the 3x, we can easily get a solution from there. To get the other solutions, we have to factor this thing. All right. All right, now, how can you factor this? Well, it's a trinomial, right? You know, it's a trinomial, 3 terms. It's degree 2. So let's try the AC method. If I tell you to use a certain method when solving these equations, you have to use that method. But if I don't tell you and I just say solve like this, you really could use any method you want. I mean, after factoring, I'll solve this using the quadratic formula. But here, well, we do 2 times -2. That's equal to -4. So we want two numbers whose product is -4, but the sum is 3. 3 is the coefficient of x. Well, again, okay, so what numbers do that? Well, you can see right here. Even without here, even, you know, on an exam, you should be able to see that, oh, well, how about 4 and -1? So that's what we get. Okay, so so we know 3 is equal to 4 plus -1, right? So 3x is equal to 4 plus -1 times x. I'm just replacing 3 with this sum, in other words. Okay, I'm missing a term now, aren't I? Should be a -2 here. Sorry about that. Okay. There we go. Okay, and then what do? We can distribute this x. Wait, let me draw it in. There we go. Right? Once you do that, we distribute the x like so. And so we have this. We have 2x squared plus 4 times x plus -x, which is -1 times x minus 2. Okay. And then remember, we have to use factor by grouping. So we get this here. Right? The first 2 terms form a group, the third and fourth term form a group. I mean, this may not work, but if it doesn't, you just try another grouping. Keep in mind also, I think I say this on the next slide also, that the second, let me go over here, the second and fourth term, they're opposite in sign, right? One's positive, one's negative. That's how you know from the second grouping, you're going to have to factor out a negative. Might be -1, but you have to factor out a negative from the second group. And yes, I did say that from the second binomial, yeah. Okay, so we now have to factor each of these groups now. Okay, Well, from the first group here, 2x squared plus 4x. Okay, so the GCF here, right? Well, hopefully you can see that b, which is the greatest common factor of the coefficients, b equals 2 is the greatest common factor of 2 and 4. Mostly because 2 is a factor of 4, and 1, m is 1 because 1 is the smallest exponent of x. So, I mean, yeah, the GCF here is 2x, so we just factor that out. And that's what I'm doing to the right, as you can see. You know, when you put it out in front, you have to see what's left over, so you divide. So we divide 2x into each term. Okay? You get this. So we have 2x in front. When you divide, the 2's cancel. X squared over x, subtract the exponents, right? You get x to the first, which is x. 4x over 2x, that's just 2. The x's cancel. 4 over 2 is just 2. So we get this. Now for the second one here, okay? Here, we want to factor out a negative. Now also notice, though, that there's a non-zero constant term, right? So that means m is 0 in the GCF of this. In other words, you can't factor out x from here. And also, a coefficient is -1. And if a coefficient's 1 or -1, that means your b is going to be 1, your greatest common factor. So in other words, the only thing you can factor out from this is -1. And that's what I'm doing.